Hello, my dear little bugs. Welcome back to my channel yet again. So, today let us understand hardness of water by doing the experiment. So, when we speak about hardness of water as such, it is the measure of the concentration of the trivalent metal ion, primarily calcium along with magnesium, so which is present in the water. So, when we say hardness of water as such, it is the property of the water which is going to prevent the formation of lather with the soap, that is majorly due to the dissolved calcium and magnesium ions. Okay, so there are two types of kind of like hardness. The first type is temporary hardness, the second type is permanent hardness. Okay, so when we speak about temporary hardness, so temporary hardness is mainly because of the bicarbonates of calcium, magnesium present in the water, and we can remove this particular temporary hardness by boiling the water, which decomposes your bicarbonates into carbonates, so forming the precipitates. When we speak about the permanent hardness as such, it is actually caused by the presence of sulfates, chlorides, nitrates of the calcium along with the magnesium. Magnesium sulfate, magnesium chloride, and magnesium nitrate as such. Okay, so this cannot be removed by boiling. It requires chemical treatment for the softening process. So water is actually classified into different categories. Okay, so based on the concentration of hardness expressed as mg per liter of calcium carbonate equivalent. Okay, so here in this particular table, I have written from 0 to 60 mg per liter as calcium carbonate, which is coming under the category soft water, 61 to 120 moderately hard water, 121 to 180 hard water, more than 180 very hard water. So, what is the difference between soft water and hard water? Okay, so when we speak about this soft water, okay, so this soft water is actually having a kind of like a very, very low concentration of calcium and magnesium ions. Okay, so it ranges from 0 to 60 mg per liter of calcium carbonate, okay, as calcium carbonate, sorry. So it doesn't form any scum with soap, okay, so soap is going to lather easily. So mainly preferred for domestic as well as industrial use, okay, where the scaling must be avoided. Okay, so if you're actually adding an indicator, we'll be discussing about this indicator in the further slide. Okay, but if you have the soft water in your hand and if you add EBT indicator, areochrome black tea indicator, okay, so the water turns blue in color, indicating that the water is soft. Okay, now, when we speak about hard water, as such, now we'll be speaking about hard water. Hard water, when we speak about, so it has a higher concentration of calcium as well as the magnesium ions. So more than 60 mg per liter as calcium carbonate. So it forms the scum with the soap. It's going to reduce the cleaning efficiency. Okay, so it causes scaling, it causes corrosion in pipes, okay, boilers and machineries. So better to use soft water in the industry as well as the domestic. So, what are the industrial applications of doing this experiment, that is hardness of water? Why we have to estimate this, okay, in the industrial area? The first thing is that boiler feed water. So, hardness can lead to the scale formation. It's going to reduce the heat transfer efficiency. It's going to increase the fuel consumption. Okay, so scale can cause boiler tube to fail. So, to avoid this scenario happening in the industry, okay, so we will be actually estimating the hardness of water. If we speak about the textile industry as such, now the hardness is going to affect the dyeing as well as the washing quality. So this causes the kind of like fabric stiffness as well as damage. To avoid these scenarios happening in that textile industry, we'll be estimating the water's hardness. Okay, if you go for food as well as the beverage industries, so when we speak about food and beverage industries, now the water, okay, hardness can affect the taste. It's going to affect the quality, it's going to affect the shelf life of the products. Okay, those, so the scaling is even going to affect the equipment's hygiene, okay, its performance. To avoid this, we'll be estimating the water's hardness in the even in the food as well as the beverage industry. If we speak about pharmaceutical industry now, it requires soft water, okay, for the formulation to avoid the contamination as specifications as such. So to avoid these, we'll be using soft water. So it's compulsory to estimate the hardness of water. And if you go for paper industries also, okay, so hard water can cause defects in the paper's textures, quality. So even for that purpose also, even industries prefer soft water, not the hard water. So, so what is the kind of like benefits, okay, of checking the hardness of the water? It's going to prevent the scaling, okay, of the boilers, pipes, okay, and other appliances. It's going to reduce the soap wastage also. Hard water is going to react with the soap becomes scum, okay. So it's going to reduce the soap wastage, improves the efficiency of water heaters, industrial systems, okay. Even it's going to protect the fabric, okay. Soft water is better for laundry, okay. So ensures proper water treatment, okay, help in selecting the right softening method, okay. So all these things are kind of like benefits of kind of like a course why we have to estimate the hardness of. So let us understand this particular experiment via principle. Okay. So the reagents used for this particular experiment is EDTA, first one. Okay, that is ethylene diamine tetraacetic acid. So the reagent used is EDTA. This particular EDTA is a chelating agent. Okay, that binds with calcium as well as the magnesium ions. Indicator used over here is EBT, Eriochrome black tea indicator. This forms a wine red color complex with calcium as well as the magnesium ions under the alkaline condition. Okay. So what is the reaction mechanism over here? So under the alkaline condition, if the sample contains calcium or magnesium, when you add EBT indicator, it turns into wine red color. Okay, so upon titration with the EDTA, okay, so EDTA is actually kind of like strongly binds to this calcium and magnesium compared to EBT. Okay, so when you titrate it against EDTA, EDTA binds with the calcium as well as the magnesium ion to form a colorless soluble complex. Okay, so when all the calcium, when all the magnesiums are complex by your EDTA, now you have left out with the free EBT. Okay, so free EBT left in the solution turns blue in color. Okay. So if you have the EBT binding with the calcium and magnesium, wine red color. If the EBT is fully free, there is no calcium, there is no magnesium, then it is going to turn into blue in color. So change color from wine red to blue indicates the point. Okay, so it's a pH control is very important. Okay, titration must be conducted at the pH 10, okay, plus or minus 1, okay, for the accurate results. Okay, so you should remember at pH 12, the magnesium precipitates as a magnesium hydroxide, only calcium remains in the solution. Okay, so maintain pH 10. So when we speak about hardness, okay, ions in the water, calcium and magnesium ions will come into picture. These ions react with certain chemical solution influencing the hardness of water, right? So when we speak about the role of eriochrome black tea indicator, EBT is a dye which is going to form a kind of like a colored complex with calcium and magnesium ion, as we have already discussed, okay, under the alkaline solution. So EBT binds with calcium and magnesium, it's going to form a wine red complex. Free EBT, you will be having blue color. Okay, so what is the role of EDTA then? EDTA is a hexadentate ligand. Okay, so it's a hexadentate ligand with the six donor atoms with it. Okay, so which can tightly bind with kind of like a metal ions like calcium as well as the magnesium. So EDTA forms stable, colorless complexes with these metals. Now, when we start with the titration process as such, okay, so initially, the solution contains calcium and magnesium ions bound with the EDT, showing the wine red color. When EDT is added, okay, it binds with the calcium and magnesium more strongly than the EBT. Okay, so displacing the EBT from the metal complex. Okay, so as calcium and magnesium binds to your EBT, sorry, your EDTA, so the EBT is actually released. So the free EBT, whatever it is released, changes the color from wine red to blue. So the blue color, okay, will change, okay, from the red to blue color indicates the end point in the titration. Okay, so that is very important. So basically, okay, so this is just a table what I have formulated. So starting, you will be having calcium, magnesium, and EBT complex, wine red. Adding EDTA before endpoint, EDTA binds with this, displaces EBT, somewhat wine red, and when you add more EBT, as soon as when you add more EBTA to sorry EDTA to the water which contains calcium and magnesium which is already bind to EBT, now EBT starts to displace. So from wine red color, somewhat turns into purple color. After purple color, when all the EBT is free, at that time it turns into blue color. Okay, so at the end point, you will be having the free EBT color changes into the blue color. So total hardness as calcium carbonate mg per liter is equal to, okay, so volume of EDTA added into 1000 divided by the volume of sample taken. So this is just a dummy readings what I have printed over here. So overall volume it is actually been added. Concurrent reading is important. 1.2. So 1.2 into 1000 divided by 50 is equal to 24 mg per liter. Okay, so it indicates it comes under the range 0 to 60 mg per liter as calcium carbonate, which indicates the soft water. 24 comes in the range of 0 to 60, right? So it is a soft water. So total hardness in terms of calcium carbonate in the water sample is 24 mg per liter, indicating the water is soft.
Hello my dear little bugs, welcome back to my channel yet again. Today let us discuss estimation of hardness of water sample. So it is the measure of concentration of dissolved minerals like calcium and magnesium present in the water. Now these minerals usually originate from the dissolution of limestones, chalk and other mineral deposits as the water passes through the soil as well as rock. Now the water hardness is important parameter because it's going to affect the domestic use. Okay, so like hard water can cause scaling in boilers, okay, pipes and kettles, reducing their efficiency. If you tell in industries, it's going to interfere with soap and detergent effectiveness and cause the faulting in the machinery. So it's very crucial to determine the hardness of water in these sectors like domestic purpose as well as the industrial purpose. So let us begin with the experiment. So we have to take 50 ml of water sample, 2 ml of buffer and pinch of EBT and titrate it against EDTA. So after taking all these things, just imagine you have taken 50 ml of water sample, buffer also has been added and EBT has been added. Okay, so EBT is going to interact with the calcium and magnesium ion, okay, and it forms a complex wine red color, okay, and this wine red color complex has to be titrated against zero point 0.1 molar EDTA. Okay, so when you titrate it against EDTA, now EDTA is going to bind with the calcium as well as the magnesium, okay, which is actually more stronger compared to the EBT, and it starts to take the calcium and magnesium from the EBT. No sooner when you add more amount of EDTA, you will be having free EBTs in your sample solution. So when all the calcium and magnesium is taken up by the EDTA, you will left over by the free EBTs in the water sample. So the free EBT now, okay, will be in the blue color. So wine red color indicates that the water sample, okay, contains calcium and magnesium, and the EBT has been kind of like formed the complex with the calcium and the magnesium in the water sample. So no sooner when you add EDTA, it from the wine red color it turns into somewhat purplish color. Then when all the EDTA has been kind of like utilized calcium and magnesium, free EBT, okay, will be turning the sample solution into blue color. That will be the end point. Okay, so at that time you have to stop the titration of the experiment. So this is the wine red color, the initial, and the end will be the blue color. This is the table. So this is the table, okay, after getting the end point that is blue color, use the formula given over here. Just imagine it's 1.5 is the total ml. So 1.5 into 1000 divided by 50 ml of water sample taken, and you will be getting the result. So looking into that result, you have to classify whether your water sample is soft water or moderately hard or very hard using the table given. I've already uploaded the video for calculation. Please do watch it, like and subscribe. Thank you.
Okay. So why does the plain tap water turns blue with EDT? Okay, this is a question from my side. So in the comment section, you can just try to answer it out. I've already answered it in the previous, like while explaining what is EDT. So please do answer the question in the comment section. Thank you.